Good afternoon, sir. This is Monica. I am from 2nd CSC B section, bearing roll number 234G1A05A1, and I am giving the presentation of projection rings. Introduction to projection rings. Projection rings are specific type of ring in algebra that related to the concept of projections in linear algebra. They are important in the study of operating algebras and functional analysis. Understanding projection rings can provide insights into the structure of certain mathematical objects. Definition of projection rings. A projection ring is defined as a ring containing idempotent elements that act as projections. An element in a ring is idempotent if P2 is equal to. Projection rings often arise in the context of vector spaces and modules. Properties of projection rings. Projection rings have unique algebraic properties, including the existence of a zero element and an identity element. The set of idempotents in a projection ring forms a Boolean algebra under certain operations. These rings can be decomposed into simpler components known as direct summands. Examples of projection rings. A classic example of a projection ring is the ring of n times n bar times n matrices over a field. The set of all projection operators in a finite dimensional vector space forms a projection ring. Another example includes the ring of continuous functions on a topological space that take values in a Boolean algebra. Applications in linear algebra. Projection rings are used to describe linear transformations that project vectors onto subspaces. They provide a framework for understanding n-spaces and invariant subspaces in finite dimensional spaces. The concept of orthogonal projections is closely related to the structure of projection rings. Connection to functional analysis. In functional analysis, projection rings can characterize bounded linear operators on Hilbert spaces. They play a crucial role in the spectral theory of operators, particularly in the study of self-adjoint operators. Projection rings help in the classification of certain types of operators based on their spectral properties. The role of idempotents. Idempotents elements in a projection ring can be interpreted as projections in geometric terms. The presence of idempotents allows for the decomposition of ring into simpler, more manageable parts. These idempotents can also represent different subspaces within a vector space, revealing structural insights. The Boolean algebra structure. The set of idempotents in a projection ring can be organized into a Boolean algebra. This structure allows for a formulation of logical operations such as conjunction and distinction. Understanding this algebraic structure can lead to deeper insights in both algebra and topology. Recent developments and research. Ongoing research in projection rings focuses on their applications in various branches of mathematics. New findings explore connections between projection rings and quantum mechanics, particularly in quantum states. Researchers are also investigating the computational aspects of projection rings in numerical analysis. Conclusion. Projection rings are rich area of study that intersects various fields of mathematics. Their unique properties and applications make them an essential topic in both algebra and analysis. Continued exploration of projection rings promises to yield valuable insights into mathematical theory and practice. Thank you, sir.